Hey, what's up guys, this is Akshay from AS Learning, and today in this video we'll be seeing about RAG fusion. Okay, so before seeing RAG fusion, let's understand what is RAG. RAG stands for Retrieval Augmented Generation. Okay, and it's a very popular technique these days, and the ones who are reading about generative AI, they must have heard about it also. Okay, so how does it works and what exactly it is useful for? We know that these popular models hallucinates. So what do you mean by hallucination? By hallucination, it means that it is giving wrong answers. Let's say if I asked him, tell me about Sachin Tendulkar, and let's say if he says that Sachin Tendulkar is a great golf player, so it is giving wrong information. That is, it is hallucinating. Okay. Now, this is a problem which is faced by every model. No model is perfect. Every model faces the problem of hallucination. So how to control it? There are different ways to control it. The most popular way is RAG, okay, Retrieval Augmented Generation. Okay, what we do in RAG is we store the database or the contexts which we want in the form of vector DBs. Okay. So for example, if let's say for example, I have a PDF or a CSV, okay, and we have observed that the model hallucinates if I ask questions on those PDF, or let's say if it is such a data which is not available to the model only. We know that GPT 3.5 has a restriction up to 2021, and GPT 4, which is a paid version of $23, it has a restriction up to 22. And it's a recently published topic. Let's say what is the score of what is the performance of India in this recently occurring ICC World Cup, for example. It won't be able to answer it. Okay, or let's say if I have a PDF, let's say a big book, and I want to answer questions specific to that book. Okay, model will hallucinate here. Okay, so what to do? So what we can do is we can store whatever thing which we really want to ask questions into the form of some vectorized contexts which are every time available for the LLM to answer. Okay, and then we can take help of these contexts. Okay, one way is that you can hypertune your LLM on that data. It is a costly process, and but let's say for example, it's just one PDF. There's no point in fine tuning it. Okay, there's always fine tuning and using LLMs. In some cases fine tuning is good, in some cases LLMs these vector DBs are using these vector DBs is good. Okay, so let's say we have a PDF, and now what we need to do is we want to have a system where I can answer questions on those PDFs. Okay, I want to be able to have questions on those PDFs. So what I'll be doing is I'll be breaking down that PDF into small chunks. Okay, I'll be setting some parameters which will be helpful to me, like chunk overlap and all, so that the information flows between the chunk. Okay, and then these chunks will be converted into vectors and stored into vector DBs. Okay, now how will these chunks be converted into vectors? We will be taking help of some model. Okay, maybe ADA or All Mini, some kind of a model. Okay, and this broken down PDF, okay, will be converted into vectors and it will be stored into vector DBs. Okay, now next what will happen is, let's say now if I ask him a question, okay, please tell me what was the performance of Sachin Tendulkar in 2003 World Cup. 2003 World Cup, what was the performance of Sachin Tendulkar, for example. It's a PDF related to the ICC World Cup. Okay, whatever innings and performance that there has been, is a CSV or a PDF file. Now what will happen is I'm asked him a question. Okay, now this question will be converted into vectors. Okay, how? With the help of the same LLM which was used to convert the chunks into vectors. Okay, now this vector or this query, okay, this query will be converted into vector. Okay, and there we will be performing a semantic search operation on the vector DB. Okay, we will be seeing in the DB exactly what patches in the data are really helpful for this vector. Okay. Now, after the semantic search operation, some useful contexts will come from this operation. Okay. Now, this enhanced context plus the query, okay, will go as a structured prompt to my LLM. Prompt plus query plus enhanced context. So it would look like you are an expert into cricket, and with this new contexts which you have got, can you please tell me the answer of the question, what was the performance of Sachin Tendulkar in 2023? Okay, and then my LLM will make the best possible answer from this prompt plus query plus enhanced context, and then it will give the response. Okay, in this way we can control hallucinations. Okay, there's no need to do the expensive fine tuning thing. Okay, and even the contexts are available to you every time. Okay, it's a better method over fine tuning. Okay, so yeah, this is how general RAG works. Okay, you are augmenting generation from the retrieval, hence RAG, hence retrieval augmented generation. Okay, this is how entire RAG works, simple RAGs. Okay, now there are lots of variation and lots of research paper in this flow into different pieces. There are different kind of retrievers like self retriever, then a hypothetical retriever, parent retriever, merger retriever. There are different kind of algorithms for retrieving. Okay, so it's a lot of things happening behind, but this is how the entire flow is from above. Okay, now the thing which we'll be discussing would be RAG fusion. Now, how is RAG fusion different from RAG, and what is so special about RAG fusion? Okay, so before starting with what RAG fusion is, you shout out to the guy who is behind RAG fusion. Okay, this is the GitHub repo of RAG fusion, Raudus SL. Okay, okay, so he's the main guy behind RAG as per my read. Okay, but I can be wrong. Okay, he's, I think, a product manager, and yeah, okay, as per my read. And this below code also which you are seeing is taken from his GitHub only, where we'll be seeing how RAG fusion is implemented and how it is different from normal RAG. Okay, so let's first see the code. Okay, no, I think let's first see the theory of how RAG fusion is different from RAGs. Okay, and then we'll go to the code. It will be much easier. Okay, so we understood what RAG is. Okay, we understood what retrieval augmented generation is, and now we'll be seeing what RAG fusion is. Now, what we saw that in the RAG flow, what is happening is there's one query. Okay, one query is being converted into vector, and then we are doing semantic search operations. We are getting the contexts, and then with the structured prompt, my LLM is giving an answer. What we saw that if we change the query a bit, okay, if we change the query, its format, its design, its grammar and all, the contexts coming are different. Okay, now what? Now this sometimes into a simple question it won't matter, but let's say if the question is very complex, okay, which requires lots of elements in pieces, that is where the trick comes into play, and that is where how it works is we want the best possible contexts from vector DPs. Okay, now how to enhance this process? Okay, how to enhance this process? What we can do is, let's say instead of asking him just one query, why not ask him lots of queries? Okay, and then whatever answers we are getting from the vector DB, let's combine it up. Now, how to bring up these lots of queries? Okay, now the first part behind this thought process is how to bring up these lots of queries. Our user will be only inputting one question. Okay, what was the performance of Sachin Tendulkar in 2003 World Cup? Okay, now this one query being converted into lots of queries is done by an LLM in between. Okay, there will be a LLM who will be converting this one query into multiple queries, let's say 5 queries. Okay, so he converted this one query into 5 queries. Okay, and now for this 5 queries I will be coming up with my contexts. Okay, So let's say that, so there are lots of docs, for example, okay, and for these 5 queries which are generated, I will be seeing now which docs are containing the contexts and what is the score for it. And then whatever docs result I got for each of this query using reciprocal rank fusion algorithm, I will be merging them up. And then will be sending ahead in the form of this enhanced context here. Okay, and then the normal flow of the LLM would work. This is how RAG fusion differentiates from RAG. Okay, now how is this RAG fusion implemented? Okay, so now we'll be seeing the code of RAG fusion. Okay, so let's start. First, I have just done pip install OpenAI, which because I will be needing GPT 3.5 Turbo for generating my search queries. Okay, then here I'm just handling my OpenAI API key part with the help of getPass. He's asking me to enter my key, and then the key is being set as an environment variable. Okay, it's a very good way of using getPass. Previously, I used to have the key hard coded in the notebook, but yeah, now I can share the notebook without being worried about my key altogether. So it's a good way of using getPass. Okay, it is raising an exception if the key is not found. Okay, now later we have 3 functions: generate queries ChatGPT for generating the queries, for the search query. Okay, then we have a function which will be doing the vector search operation on the vector DBs. Then we have a reciprocal rank fusion algorithm, and then we have a function for combining them up. Okay, combining them up back. The combining is done here only. Okay, this is just a function for displaying the results. Okay, my bad. Okay, now let's go to the first function. Okay, all these functions are taken straight away from the main.py of RAG Fusion package. Okay, coded by Richard White. Okay, now yeah, let's go with the first function. So what is happening here is the original query is coming as a parameter. Okay, so I'll show you the original query and the docs here. Okay, the original query is impact of climate change. Okay, I'm asking what is the impact of climate change, and my database here is this. Okay, this is my all dogs database. Okay, on which the vector search operation will be performed. Okay, as you can see, we have 10 documents with some dummy data here filled up. Okay, so this is the first question: generate queries ChatGPT. The original query is being coming as a parameter impact of climate change. Okay, GPT 3.5 Turbo is used. Okay, role based prompting is done here. Okay, the system role said the content is you are a helpful assistant that generates multiple search queries based on a single input query. So you are narrowing down for GPT 3.5 very straightforward that this is the task I want you to do. Okay, then I'm telling him that generate multiple search queries related to original query, and I want total of 4 queries. So, and then whatever generation is being done, I'm just stripping it off and splitting it off and saving the queries. So I gave him a query impact of climate change, and I'm getting 4 similar queries. Okay, what those generated queries are, we'll see later. Okay, but so what this function is doing is taking the query and generating you the number of queries you want. You are using GPT 3.5. Okay, now the next thing we have is our vector search function. So what will this function do? It will do a search operation on my documents and tell me that these are the most relevant document as per your query. Okay, now this is a mock function, okay, to simulate the vector search operation. Hence all the random things are generated here. Okay, this is not keeping in context the actual vector DB. Okay, this is a mock function. Okay, so hence you can see here that random package has been used just to initialize the search scores. Okay, but in actual it will be some semantic search operations real score which has been performed on the PDF chunks and all. Okay, So here what I'm doing is I'm converting my all documents. This is my all document. These are my all documents. Okay. These are being converted into a list, shuffle, and then I am generating some. First of all, I'm selecting some random docs from those 10 docs. Okay. And then I'm generating some random scores for it. Okay. And then those scores are being returned. But in the real, how it would work is this won't be random a random selection. It will be the selection where the contexts are found for that query, and the score will be how relevant is those contexts with the query. That score will be there in real use case. Okay. Now this is the vector search. Now we'll go below. Okay. Now this function gave me my generated queries. For each query, I am doing a vector search operation. Now what it will give me is the documents where I'm getting the context and what are the score for those, and I'm storing them up. Now this I'm passing as a parameter to reciprocal rank fusion algorithm. Okay. And then I'm getting my re-rank results. Okay. And then these re-rank results are being passed to generate output function, and my final output is being generated. Okay. Now let's see how it is working. So I'll come to the reciprocal rank fusion function later. Okay. So these were my 4 queries which were generated for my original query of impact of climate change. Okay. These are my 4 queries: cause of climate change and its impact in environment, blah, 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 blah. These are my 4 queries. These were the documents which were randomly selected, and this is the random score which is generated. Okay. So as per them, how it will happen in real application, it will be like this query of causes of climate change and its impact on environment will have a semantic search operation on the chunks, and then those chunks with the respective scores will be here with us. Okay. This is what we have into our all results. Okay. And now what we'll be doing is we will be executing a reciprocal rank fusion. Okay. Now what this is, we'll go to that function. Understand the reciprocal rank fusion algorithm. Okay. Here it takes the search result dictionary which is coming from vector search, and k is equal to 60. Now what is this k is equal to 60? This 60 is nothing but the number of words in my documents. Okay. Right. Now what we will be doing is we will be going for every query, for every document, we will be calculating their fusion scores. Okay. How are this fusion score calculated? It is 1 upon rank plus k. Okay. This rank is nothing but the rank for that query of that document. Okay. See here, we have 4 queries, 1, 2, 3, 4. For the first query, I had document 4 with highest score, document 10 with somewhat less, and document 6 with less. So this tells me that when this query had a semantic search operation on the vector DB or this above sample documents, this document was the closest with highest contexts in the scores. So this will have the lowest rank at the top, rank 0 to doc 4. Then doc 10 will have rank 1 and doc 6 will have rank 2. Okay. So what we are trying to do is we are going query by query for each doc, and we are telling that the one with the lower rank should have higher score and the one with the higher rank should have less score. Okay. In this way, we are calculating the fusion scores for each of the doc. We are merging all these scores together, right? And then this merged scores are being sorted, and a final result is given of this entire re-rank activity. Okay. Let's see how the scores are updated. First query. Okay. For first query for first document, because it is at rank 0. Okay. The score which was at 0, it got updated to 0.01666. okay, because it is at the highest rank. For next document, the score will be somewhat less, right? 1639. For next document, somewhat less, 1612. Okay, then we'll go to the next query, that is the economic impact. Now in economic impact, we had doc 5. Okay, now doc 5 was initialized to 0, so it got a score of 0.01666. Okay, then the next is doc 3. Okay, this was also at 0, it got a value of 0.0639. Now the next is doc 4. Doc 4 also came in query 1 and it had a score updated to 0.066. Hence, for doc 4, now we will be doing one more updation. It will be from 0.06666 to 0.03279. Okay. In this way, for each of the doc, the scores are updated. And finally, we have our re-ranked score. And the final re-ranked score is that doc 3 has the highest score. And then doc 4, then doc 6, then doc 8 and doc 5. Right? This is our re-rank output. So in this way, what we did was we fused all those scores coming from individual queries. And then this final score, okay, tells us about the most similar contexts, okay, and then this enhanced contexts will come here, prompt plus query plus enhanced context, and this will go to LLM. Previously in normal RAG, what was happening? Now in RAG, what was happening was we had this one query, it was doing semantic search operation on the vector DB, the context was for coming and then going to the LLM. In RAG Fusion, what is happening is the one query gets extrapolated to 4 queries, and then those individual queries give their own individual documents with scores. We are fusing them up. Okay, we are fusing them up using reciprocal future ranking algorithm, and then this enhanced context coming from this 4 queries is being passed to the LLM, and that is how RAG Fusion separates from RAG. Okay, so this is what I had in this video. Okay, we saw how RAG is different from RAG Fusion. So RAG Fusion is different from RAG, and then we also saw the code for it. Okay, so huge shout out to the GitHub of Raudes SCL. Okay, I think his name is Adrian Raudes SCL. Okay, yeah. So yeah, so huge shout out to him. Okay, so yes, this is how RAG Fusion is different from RAG.